First of all, I would like to say, give a big thank you to Mr. David SCHMIDT, who's going to be presenting next. He is our conference's main sponsor, and this has been a pretty tough year. And if it wasn't for his, him and his company's generous sponsorship of this conference, it might have not have happened. And so please give a round of applause to Mr. David SCHMIDT. It was an absolute tremendous help. Thank you very much. So David has an extensive background spanning over 30 years, owning various successful companies in manufacturing and product development. His education includes management information systems and biology from Pace University in Pleasantville, New York. Peter Lindemann and I and a friend Victor and Peter's wife Jackie had the privilege and the honor of having dinner with him last night. And I can tell you that the depth of his knowledge and just the scope of everything he's been involved in is absolutely profound. He's one of the most successful people I believe that I've met and had the privilege of being able to talk to and kind of pick his brain on a few matters. One of the companies he owned was Advanced Application Group, which is a R&D center for energy production technologies for military and commercial applications. And during this time, he developed new methods for producing hydrogen and oxygen, and designed and prototyped multi-field, bladeless Tesla turbine power generation systems, and constructed metal combustion rocket engines. So he's been involved with quite a few exciting technologies. And as a result of this, he was presented with an honorary doctorate by Dr. Alexander Marinaccio of the International Hall of Fame of Inventors. And because of his design of an emergency oxygen system for General Dynamics in the U.S. Navy, he was invited to participate in the Navy's next generation mini-sub program. He currently holds 94 issued patents and 13 pending patents, with quite a few more which are currently being written. And over 70 of these are related to regenerative science and technologies, which you're going to hear about. What Lifewave is about is heavily related to the regeneration field. And this technology, which is the subject of the next presentation, was born out of 3 years of intense research into the concept of increasing energy and stamina through elevation of fat burning, utilizing wireless communication to the human body via phototherapy, one of my favorite subjects. And this is now finally available to the public, and he has spent 15 years making this opportunity a reality for everybody. One of his inventions, the double helix conductor, produces a novel blend of electromagnetic but also longitudinal waves to improve the speed of wound healing that rivals that of stem cell injections. And this kind of led to him realizing that the phototherapy can be a means by which a person's own stem cells can be activated into a more youthful state, as opposed to requiring an injection that's both expensive and potentially dangerous. Hence, after 10 years of study, the X39 patch, where you're probably going to hear a lot about this, was born. I probably won't lift my shirt up too high, but I'm actually using 2 of them right here for about a year, and I'll be happy to give my testimonial later, as well as Peter, Jackie, my friend Victor, and some others that are here this weekend. And since the inception of Lifewave in 2002, David has overseen the global operations of this company that has accelerated expansion in approximately 100 different countries, with offices currently in the US, Ireland, Japan, Taiwan, and with warehouse and distribution facilities throughout the world. And Lifewave has also been a multiple recipient of Inc. magazine's list of fastest growing companies. Please help me welcome Mr. David SCHMIDT.
Thank you, Aaron. Appreciate that. Thank you very much. Wow, thank you very much. That's very kind. And could you give a round of applause to Aaron and Peter for putting this whole thing together? It's really great. So I know we're going to be talking about stem cells and regeneration today, and ultimately the goal that we would like to achieve in our research at Lifewave is to speed up the regenerative capabilities of human beings and go in reverse with aging. And I'm going to share a little bit about that with you today, about what we've actually achieved and in our research and where we see this going. But the end of the story is that we see practical age reversal as being more near-term than not. Just like stem cells will be an everyday part of life, you'll be able to walk into a clinic or a hospital and get a stem cell injection that may happen in 10 years or 20 years. And the same is going to be true with reversing human biological age, where technology will be in place, where people can live to be, they'll look and feel 30, 35 years old, and we don't know yet what the upper limit of lifespan is going to be. But we're going to be talking about some of those mechanisms and the journey that we've been on for about the past 20 years or so in trying to understand this and implement technology. So if no one is interested in that, I did bring a gold coin with me that we made in our lab, and we converted tin to this gold-like coating. So if you're not interested in reversing age and you're interested in things like making gold, then I'm going to tell you how we did that. So maybe somebody will be interested. I don't know. We'll see. So our primary focus is on stem cells and regeneration, and we have explored in our labs quite a bit of territory. Predominantly, we've looked at the role of phototherapy, so light therapy, electromagnetism, longitudinal waves, devices that will produce these effects. And the basic principle is, instead of injecting stem cells into the body, why don't we take the stem cells that are already in your body and reset them to a younger, healthier state. So a stem cell is a universal cell. We all have stem cells in our body, and every cell that you have now, whether or not it be muscle tissue, liver, kidney, heart, whatever, was once a stem cell. And so a stem cell is going to divide and differentiate. It'll go from, let's say, a induced pluripotent stem cell down to a multipotent stem cell, and then down into differentiated tissue. That's a very simple explanation. But as we age, the stem cells are going to age with us. So one of the approaches on age reversal, which again will be available to the general public 10, 20 years from now, is you'll be able to get an injection of stem cells that are 18 to 25 years old. And as long as those stem cells are compatible with your body, they will divide and become healthier tissue. So this is incredibly exciting, because what it means is, in the future, instead of us having to worry about diabetes, heart disease, kidney failure, hardening of the liver, we'll be able to, instead of having operations, non-invasively, we'll be able to use energy medicine devices, and we will be able to use injections of stem cells or other techniques and replace that old damaged tissue with younger cells. So instead of having a quadruple bypass surgery, now you've got a young, healthy heart, as an example. So that's what's so exciting about the future as far as where this is all going. So let's look at what we can do today, right? Most of us, we like to have a solution today and not 20 years from now. So what can we do? Let's address the problem. The first thing is that stem cells are going to age with the rest of the body, and they are limited in lifespan currently, like the rest of our cells. So this is often referred to as the Hayflick limit, meaning the number of times a cell can divide before we can't make any new cells. And this has to do with telomere shortening. So one of a number of principles in age reversal is that we have to keep the cells dividing, and that means we have to find a way to control the lengthening of the stem cells. Stem cells also slow down as they age. We did some of our work at the National University of Ireland in Galway, and I should tell you that over the last 20 years, we've done over 80 clinical studies on our products and in the field of stem cells and regeneration. So there's quite a bit that we know about this subject, and there's still more, of course, that we're always learning about this. But if you take donor stem cells from someone over the age of 60, one of the things that you'll see is that these stem cells have slowed down in their motility rate, and their ability to release growth factors, which is going to repair damaged tissue, declines as well. So this is really intuitive, right? We know that as we get over the age of 60, we don't heal as quickly, we're not making as many new cells, and this is pretty obvious. But what's going on underneath this is that the stem cells are declining in number, and they're declining in their efficacy. So we want to know the reason behind this. And by the time we get into our mid-70s, for all practical purposes, we've run out of stem cells. And this is a real problem, and it explains why people, after they get into their mid-70s or so, if they get into an accident, it's very, very difficult to heal and recover from that accident. So you have somebody in their 80s or 90s, they break a bone, and they may not be able to heal and recover. So first, the good news is that regardless of your age, even if you're in your 90s, we found in our research you can still activate stem cells and create new stem cells, and you can lengthen telomeres. So that's the good news. No matter how old you are, hope is not lost, okay? So that's a good thing. All right. So why don't we just use a stem cell injection if stem cells are this good? Because there are stem cell injections that are available today. Generally, the way that they work is you'll take stem cells from your own body. They could come from the bone marrow, they could come from body fat. They're concentrated and then injected into the site of the body where you need them. The problem with this is that if you're over the age of 50 or 60, the quality of those stem cells are not going to be very good. There have been services available where for people that are in their 20s, 30s, or 40s, you can harvest your stem cells, have them frozen, and then use them later on in life. But that's expensive, and most people are not going to do that. The other types of stem cells, one is called MSC, mesenchymal stem cells. Most countries have not approved the use of stem cell injections. In early research, as an example, some research that's been done into treating Parkinson's disease in Japan, stem cell injections were given, they were injected into the brain, and the primates died, the monkeys died during the testing. And when they opened up their brains, they found that inside were hair, muscle tissue, liver tissue, and the stem cells divided in an uncontrollable fashion. This can even happen with your own stem cells. So there can certainly be side effects. For example, you can inject stem cells in the body, and instead of it becoming liver tissue, it can become bone. So stem cell science today is not mature. It hasn't gotten to the point where it's available to everybody. More research is required. Stem cell injections certainly can work, and many people have had success with them. And then sometimes you inject stem cells and they don't do anything at all. The reason is because let's say that you have bone on bone in one of your knees, and you want to get a stem cell injection to regenerate the lost cartilage. The problem is there's a lot of inflammation around the injury. And paradoxically, the stem cells are attracted to the inflammation, but the inflammation also kills the stem cell, a little bit like moth to a flame. So we need inflammation. It's part of the signaling process to get stem cells over to where they're needed, but if the body's not managing inflammation, like is the case with chronic disease, then the problem is going to be the stem cell colonies, they die off, and the injury goes on, and we don't heal as quickly. So these are all some of the things to consider when we're looking at stem cell technology. A lot of different components that we have to address. So can we utilize stem cells in the body and make them behave like younger, healthier cells? This was one of the objectives of our research. And if we could do this, we would be able to obviate the need for stem cell injection. So imagine, you already have stem cells in your body, and they already know what to do. So if we could just find a way to get them to behave like younger cells, it's going to be incredibly safe, inexpensive, and very efficacious. So we've produced well over 70 patents on different technologies in the field of stem cells and regeneration, and so we've learned quite a bit about this over the years. We've done research work predominantly in the United States, but also in other countries. We operate a 75,000 square foot manufacturing facility in Galway County, Ireland, which is on the west coast of Ireland. And that's a hub for medical research. So every major medical company, pharmaceutical company has an office on the west coast of Ireland. And the National University of Ireland in Galway is one of the top stem cell research centers in the world. So we were very privileged to make a proposal to Dr. Tim O'Brien, who runs their Regenerative Medicine Institute, and he accepted the proposal. We were funded by Scientific Foundation Ireland, and then we went about doing our research there. So this is one of the technologies that came out of this development program. We had started this project around 2008, 2009, and I'm an inventor like you guys, but I always tend to think that inventing is just kind of like a process where you pray and hopefully God blesses you with information, and then you do something with it. So I used to think I was a pretty good inventor. Now I just think I'm just kind of a vessel, you know, for downloading. So take that for whatever it's worth. But I was kind of given this insight into, hey, you should make a coil that resembles DNA, and here's some of the things you should do with it. So we started to, fortunately, I work with this amazing engineer. He's one of the top 3D designers in the country. So he would go into companies like General Dynamics and train their engineers on how to do 3D design and 3D manufacturing. So he works on our staff in our research and development. So we have a bank of 3D printers and design software. And so one of the things that we started with was to start to model these DNA toroidal coils. So once we had them modeled and we started printing them, we started to think about, you know, how do you wind these? What frequencies do you use? You know, all the standard kind of questions that you might have. What frequencies are you going to drive it at? What waveforms? So in the initial going, we tried a lot of different things. But where we got to eventually was that we have 23 different versions of this, all different sizes through any one version. And they can be kind of like our standard model is 20 inches in diameter. And this one that you see here, which was just a fun one that we wanted to build is about 6 feet in diameter. So the idea is that you stand inside it, and that's on a screw drive, and it sweeps over the body. Turned out to be completely unnecessary, but it really looks cool. And what we're doing on the windings are wound around a solid rubber core. Although we did, in one embodiment, we used tubing because we put one of these coils into an incubator where we were incubating stem cells. And so stem cells have a very narrow tolerance for temperature. So even you have a little bit of heat that's given off from power that you run through one of these coils, it can take the incubator out of range, and the stem cell colony can die. So we made one of these where we used plastic tubing, and then we would run cold water through it so we wouldn't affect the temperature of the incubator. But generally, we're going to just use a hard rubber core on this. Depending on how much current, obviously on a bigger one we might use 18 gauge wire. On kind of the smaller ones we'll use 24 or 28 gauge wire. And then we'll take them, and this will be magnet wire. Then we'll take the magnet wire and we'll twist it together. And that gives us a number of pretty interesting options. So we'll twist the wire, and some of the parameters that you can play with are the number of twists per inch, and that's going to generally relate to the frequency that you might drive it at, but it's not incredibly critical. And the math that we kind of settled on for frequencies was 432 based math. So we're not going to get into that because most of you are probably familiar with it. But what we learned was that, and you can read about this in our patents, what we learned about this was that the best way to get an efficacious response was not, let's say, directly treating something with 432. All right, just using as an example, there's many different frequencies that you can use depending on what you want to do. Instead, what we found was that in the twisted wire, through one wire we would put 216 hertz, and the other wire we would put 864 hertz, and that way we developed 432 as, let's say, a beat frequency in free space. And we found out that that dramatically improved the results. Okay, so this is some work that we did at the university with what would be called a standard rabbit model. So you do your cell culture work, then you go to animal models, and then you go to human beings. That's the standard way of doing it. And so you'll take, in this case, we were looking to see if we could treat a diabetic ulceration. So you would induce diabetes in a rabbit, an ulceration is going to form, and then you look to see over a period of 7 days or up to 14 days what happens with the rabbit. You also take, this is induced in the ear of the rabbit, and so you fold over the ear so the rabbit can't scratch at it. And in a young rabbit, the ulceration is going to heal on its own in 14 days. And so what we did was we put them into the coil technology, and we found that we got statistical significance on our very first try, and we got an increase in the rate of regeneration in terms of wound closure. Now, what was interesting about this, this was our first animal study of this type. What was interesting about this is that if you took mesenchymal stem cells and you put them into a collagen gel, this is a product called Matrigel, and you applied the stem cells topically to the injury, the rate at which the injury would heal would be identical to the rate at which it healed with our device. So what that means, and what that meant to us, was that this was the first proof that we had, was that you don't have to inject stem cells. You can use energy medicine to activate the stem cells and get them to work more quickly. So that was exciting. Okay, so here's our planaria, these flatworms, and there's many different varieties of planaria. And researchers, by the way, in San Diego, one of the world authorities on planaria is right in San Diego. So we were able to invite him into our lab so he could witness this. And fortunately, the genome of the planaria is mapped. So if you're altering gene expression or the rate at which a planaria heals and regenerates, there's a way to determine what exactly is going on. So as we discussed before, first time that we went and did this, rate of regeneration was 8 days, but then we got it down into less than 1 day. There is a version of this technology where what we do is we take that coil, and instead of keeping it static, we rotate it. And there's a lot of magic that happens there. And we're still trying to understand exactly what all the effects are. But when you take a planaria and you cut it in half and you see that it regenerates over a period of time, it will go through a very predictable cycle where over about 10 hours, a blastema will form, the stem cell, you'll get wound closure, and then once you have wound closure, the stem cells can migrate to the injury site and begin the process of regeneration. We were able to get wound closure in under 15 minutes. But that only happens when you spin the longitudinal field. You don't see that in stationary systems. And I know that that is probably making complete sense to all of you, I assume. So we have not gotten regulatory approval on this device. One of the challenges is, what do you tell regulatory about how this works? Because you pretty much can't tell them the truth because they don't have a file for that, in places like the FDA or the EU Commission. It's a problem. And standard pulsed electromagnetic field therapy is only approved for things like pain relief, right? So it's going to be a long time and a lot of money before we ever get that to market. And so the thought was, okay, is there any way we could take what we've learned from all this time and money? This was $4.3 million that we spent in research, in development and clinical studies to develop some of the things that I showed you. So these devices are expensive. They have to be used by clinicians. They're probably, because of the expense, they're probably going to go into hospitals and clinics, and they're not going to be available for everyone. So how can we take this information and turn it into something that's inexpensive and available for everybody, right? That was the goal. So how would that technology work? Well, fortunately, at the time, I had, let's say it was 15 years into research into photobiomodulation and light therapy. So we had collected a pretty fair amount of data on how to turn on or turn off different biochemical processes in the cell just using light. And our technology is different than traditional light therapy. In traditional light therapy, you'll have, you pick a wavelength of light, maybe it's in the infrared, near infrared, or visible light if you go up into UV for increasing vitamin D or testosterone production. And so the way that you might look at that is traditional phototherapy is kind of like white noise. You have energy there, you have a wavelength there, but it's not encoded, so to speak, with information. So, of course, we know in the military you have laser communications where you take a wavelength of light, let's say it's in infrared, and you modulate it so that when it's received at the other end, now you have information there that can be decoded. So this was the process, or the approach that I took, was let's modulate different wavelengths of light to communicate with the cells and trigger a very specific biochemical process. And so with this approach, we've been able to upregulate mitochondrial function, increase levels of intracellular antioxidants like glutathione, elevate other antioxidants like carnosine and different peptides. And in this case, we're able to figure out how do you activate the stem cells, right, for increased regeneration. So how does this work? The beauty of this is the simplicity, is that instead of using an active device, this is encased in a non-transdermal patch. So this is a patch you apply to the body. It's completely sealed. There are no chemicals that are going into the patch, into the body. There are no chemicals in the patch going into the body. Instead, the patch is activated by your body heat. Once it's quote-unquote activated by the body heat, it will begin to reflect specific wavelengths of light that stimulate the skin. If any of you are familiar with the work of Fritz Popp, then you know that it only takes one packet of photons to activate a receptor, meaning that with very, very small amounts of energy, picowatts, we can turn on a specific biochemical pathway. The really interesting thing about this is that it just about doesn't matter where you apply it. In our research, because we use conventions and we have to have instructions for use because of FDA, we tell people to apply the patch either behind the neck or below the belly button. But in practical terms, if you wanted to put it at the site of an injury, for example, you could. But it's not necessary. It has a systemic effect. And the patch will have a backing. You just simply unpeel the backing. The adhesive is made by 3M. It's hypoallergenic. So most people, 1 in 10,000 people would be allergic to the adhesive. And then it goes to work stimulating the skin with light. So technically, this is known as photobiomodulation. And what that means is we're using light to trigger a specific biochemical change in the body. When I started with this back in the 90s, this in the public domain, this was considered quackery. Behind the scenes at the Navy, we were developing survival equipment, and DARPA was investing well over $10 million. There was one researcher, his name is Dr. Harry Whelan. He was a captain in the Navy, and he was looking at a mechanism called photo repair, where you can take very, very small amounts of light and trigger a regenerative effect. So this was something in the military that they knew worked, and they wanted to use very advanced light therapy for healing wounds. So the idea is you could have a next generation hospital that would be behind the front lines, if you will, and you could get someone that was injured, fly them back, and then put them in a light therapy bed and start to trigger regeneration very rapidly. But out in the public, it was quackery. What changed was that in about between 2006 and 2008, research started coming out that showed if you stimulate the skin with near-infrared light and some other wavelengths, it elevates the enzyme cytochrome C oxidase. And cytochrome C oxidase is part of what's called the electron transport chain in the cell, and this is the process by which the cell makes energy. So now there was a mechanism to understand how when you stimulate the skin with light, this leads to an increase in mitochondrial function and an improvement in a number of ways that the cell works, such as improving collagen synthesis. So today there's over 5,000 clinical studies on photobiomodulation, and a lot of the work has come from Michael Hamblin out at Harvard. And Michael Hamblin has over 400 published studies in this. So it's quite well accepted. So the question is, if you're trying to use light to activate the stem cells, how are you going to do that? And what we found in our research was that we wanted to target the light therapy to elevate a peptide called GHK-Cu, or copper peptide. So copper peptide was actually discovered between the late 1960s and the early 1970s by Dr. Laurent Picard. And he's put about 50 years now of research into investigating copper peptide. And what he and his associates found was that for a very simple 3 amino acid peptide, it does some things that it shouldn't do. And part of the reason is that copper peptide has a phenomenally high affinity for copper. So GHK binds with copper in your body. And when that happens, it will act as a very powerful gene modulator. So when Dr. Picard and others were doing some of the initial research, they found, oh, this is activating stem cells. It's increasing collagen production. It's decreasing the appearance of lines and wrinkles. It's increasing the rate at which people are healing. It boosts the immune system. It had all of these different effects, and that didn't seem to really make much sense. But then it was discovered through doing gene panel work that what was actually going on was that copper peptide was resetting about 4,000 genes to a younger state. Now this is where the age reversal part comes in. Today, age reversal has gone mainstream. Places like Harvard, Stanford, Dr. David Sinclair has been given over $1 billion in research money from major pharmaceutical companies to develop drugs for age reversal. So this is very mainstream now. It may be 10 or 20 years before we see drugs on the market. Not that I think you should take any of those. You know, that'll be the joke, right? Like all these drug companies have. You see people dancing, singing. We'll see those commercials for age reversal, and the side effect will be death, right? So, So, what is it that we're trying to do with this? The age reversal phenomena that we see in our lab depends on a few very important things. And this is extremely consistent among species that essentially are immortal. For example, you have sea sponges that have been found to be 15,000 years old. Trees that are thousands of years old. There have been mollusks that have been found to be over 500 years old. Lobster actually gets stronger as they age, and there's been lobster that have been found over 130 years old. Tardigrades, immortal, very difficult to kill. Planaria, the only reason they die is because they get sick or there's a predator that will kill them. But other than that, planaria, their lifespan are virtually infinite. So the exciting thing about this is that nature has already provided us with models to follow. And what you see with these species is that they have perfect control over oxidative and inflammatory stress, which human beings are not so good at. Their energy production remains very consistent, never degrades. Unlike human beings, energy production degrades at about age 45 or 50. What we also see is that as cells divide in these species, like planaria, the telomeres don't shorten. So the cells are able to continue dividing. So, and the genes do not change as well. So when we're looking at practical human age reversal, one of the things that we need to be able to do to get all of this under control is lengthen the telomeres, keep mitochondrial function elevated, and we, amongst other things, we want to be able to flip genes back to a more youthful state. So as we age, genes can go on or off. So some genes get turned off and they should be on, others get turned on and they should be off. And so we need signaling molecules like peptides to get the body to turn on genes back to a younger state. And so the amazing thing about copper peptide is that it will flip about 1/3 of your genes back to a more youthful state. And there's some easy to document benefits of that, which we've done in our clinical studies. So the patch is designed to elevate copper peptide. How do we know that? Well, we've done blood studies. It took actually quite a bit of time to develop a protocol to test for copper peptide. The reason, by the way, why you don't see it on the market, if this is so good, why isn't there a vitamin pill? Why isn't it available? Well, it's because, number one, copper peptide is slightly toxic in the gut. So it's not approved for human use other than in research. And then taking peptides orally is never really very effective anyway, because the stomach acids are going to break down the peptides into their amino acids. Injecting copper peptide will work. That's what you see in many of the research studies, but most people don't want to give themselves injections every day. So for that reason and others, it hasn't been available. So we did a number of clinical studies. We worked with a laboratory in San Diego, and we just had a 60-person double-blind placebo-controlled study that published. This was our first pilot study, but both studies show the same thing, that within the first 24 hours of using this light therapy device, the levels of GHK is already going up to statistical significance. And in this study, we tested at baseline, 24 hours and 7 days, and we see that GHK and GHK-Cu go up over that period of 1 day to 7 days. So what that means is that you don't have to take a pill or something or get an injection. Just using light, you can increase this peptide, which will reset the genes, third of the genes, to a younger state, and in turn, this will get your stem cells to function like younger, healthier cells. We've also done metabolism studies using urine analysis, and this has been interesting because once you showed that the light therapy is increasing copper peptide, then the question is, okay, well, what kind of effects can we measure? Because this hasn't been available before, and how is it going to compare to some of the prior blood studies that people like Dr. Picard had done? So we've done a number of these studies, and we did a pilot study, and then this was from a 50-person double-blind placebo-controlled study. We generally work with people over the age of 60, and the reason is because the levels of copper peptide have dropped by about 60 to 80% over the age of 60. We do our studies in measuring over different periods of time. So these studies, blood and urine tests, have generally been over about 1 to 3 weeks. We have studies, I'm going to show you one that we've done using a P3 EEG system to measure what happens with the brain when you activate stem cells. Those are over a 3 to 6 week period. And then when we do some of the anti-aging and age reversal studies, those studies are over a period of 6 months to a year and longer. So what we found with this urine study was pretty interesting. The first thing is we can measure an increase in the metabolism of amino acids. So for example, let's see, how many of you exercise here? A couple of you? I wish it was all of you. Okay, but it was a lot. Pretty good amount. All right. So one of the things that we saw was that copper peptide increases the rate of leucine metabolism by about 30 to 40%. So we're currently doing a new study now with younger males, and we're putting them through a specific exercise program, strength and resistance training, and we're looking at this a little bit more closely. But basically, bottom line is that this allows you to build muscle and strength and stamina more quickly because of an increase in leucine metabolism. We see other things, for example, the amount of GABA goes up, and that helps put people into a relaxed state and also improves the quality of sleep. And GABA is interesting because GABA regulates something called brain-derived neurotrophic factor, or BDNF, and BDNF is what regulates stem cell activity in the brain. So I'm going to show you what happens there. So as a result, one of the things that we see is that in a very short period of time, people experience an improvement in cognitive function. So in these groups where we have people 60, 70 years old and above, they are in a period of a week to 30 days seeing dramatic improvements in their memory and their focus and even the speed at which their brain will process information. Heart rate variability, that's a way that we measure the muscle contractions in the heart, the ratio, high frequency, low frequency muscle contractions in the heart. Heart rate variability improves within the first week. Overall vitality, so we'll use questionnaires that are clinically relevant. So for example, when you do a study on pain relief, use what's called VAS scale, and then this measures quality of life and pain so we can see improvements in that. Even rates of respiration, breathing will improve within the first week of using X39. Okay. One of the scientists that we work with is Dr. Gaetan Chevalier, and he's a really interesting fellow. Prior to doing work on biophoton emission, which we've done a few studies with him on that, he was at UCLA doing fusion research. And his specialty is laser spectroscopy. So one of the studies that we did with him was using this EEG system, and I'm going to show you what some of these brain scans look like. But again, we work with people over the age of 50 and 60 because that's where we would expect to see problems. When people are in the clinical studies, they're simply using the product during the day and then removing it before they go to bed. So you just put it on in the morning after you get washed up and then take it off before you go to sleep. So this is to illustrate this point. This is a 77-year-old woman, and session 1 is the baseline. And session 2 is going to be after 3 weeks, and session 3 is after 6 weeks. So effectively what this is showing is changes in brain coherence. So an important phenomena in aging, and ultimately if we want age reversal, is the coherence of the cell. An easy way to think of this is that as we age, our cells go from a state of coherence to incoherence. And for those of you interested in structured water, this is one of the reasons why structured water is so important, because it can help to maintain the integrity and the coherence of the cell. But we also have to increase collagen production in the fibroblasts, because it's the collagen that makes up the cytoskeleton, which supports the overall structure of the cells. So what we see with this is you put on X39 and it stimulates the skin with light. That causes an increase in the blood in the first 24 hours, and your levels of copper peptide start to increase. Copper peptide then changes the metabolism to support an increase in the proliferation of stem cells, the number of stem cells in the body, and the quality of those stem cells. As the chemistry of the brain starts to balance out and the stem cells go to work, the brain starts to go from a state of incoherence, in this case, to a state of coherence. And you can see there's a dramatic change within 3 weeks and a even more significant change after 6 weeks. Now, not everyone is going to respond the same way. We find about 85% of the population get results their very first week, but some people, they take a little bit longer. So in this case, this was a 67-year-old man, and you can see his starting point, and then there's an improvement after 3 weeks, and he may or may not have noticed anything, but you can see after 6 weeks of use, there is a much more significant change. Now, what happens out in real life? So we went to market with this in July of 2018, and we weren't selling the product for the first 6 months. What we were doing was giving the product out to distributors and customers in the business because we wanted to see what type of effects would we get back in real life. You go from the laboratory and then what happens out in the real world. So this was a case where we had a man in Italy, and he had had a scar from open heart surgery, and July of 2018 is when he got X39. And you can see, even though the scar was there for a year, after a month on the product, there is a decrease in the scar. And the reason why this is happening is because copper peptide will help to manage inflammation, and this offsets formation of what are called keloid proteins, and then the stem cells can repair those damaged collagen structures. Here's another case, and this was a scar that was present here right after a surgery, and then within 2 weeks, there's been a significant improvement in the rate of healing. Now, the patch is systemic, meaning you can apply it behind the neck, below the belly button, and it treats the whole body. But some people like to put it at the site of injury, and that's totally okay. And in this case, this is where a person applied it near their surgery, and you can see after about a month, they get a very nice result. Now, one of our distributors over in France, her son was getting ready to go on a job interview, and he fell while snowboarding, and he got cut up pretty bad. And but you can see, after only a few days, there was a dramatic improvement. This was a really interesting case because this fellow almost lost his hand in a motorcycle accident, and you can see after about 2 months, there's barely the sign of a scar, and he regained the use of his hand. This was even more dramatic. This was a young boy in Denmark. As I recall, he was 9 years old, and he was playing, and he got his tip of his finger caught in a door, and the tip of the finger got severed. So his parents rushed him to the hospital, and the doctor said, "I'm sorry, there's not really anything we can do." And the father begged with him to reattach it, and he said, "Well, I can reattach it, but it's probably going to die." So they reattached it, and you can see what happened after that. So they started to apply X39, and he regained, within 2 months, he regained use of his fingertip. When he went back to the doctors, he said, "I wouldn't have expected something like this would be possible, and if so, I would have thought it would have taken 9 months." Now, these have all been, cases where they're injuries. What if you're totally healthy? How can we benefit from this? Because the ultimate goal of what we want to be able to achieve through our research is to put products onto the market where people can get practical age reversal. So what happens if we reset 1/3 of the genes to a younger state. How far do we get? 1/3 of the way there. This is one of our members down in Australia. Her name is Mandy Rowe, and she started using the product, and after 6 weeks, she got some pretty decent results with it. She continued using the product for a year, and you can see that the skin tightened up. And this is what happened to her after 2 years. So the reason why we have a successful business in Australia today is because she goes around to all of the meetings, and our distributors there love to show her off because people that know her, they can't believe the change that's occurred. Our very first, and we would refer to this as youth renewal, our very first youth renewal testimonial occurred in Europe. This woman that I'm going to show you is 93, and this is what happened to her 2 months after using X39. She was suffering from a number of medical conditions, and we don't make any medical claims. We're regulated by the FDA as a general wellness product. So her daughter, who's a Lifewave distributor, gave her mom the patch to just simply improve her health, and this is what happened. So she had a pretty dramatic improvement in her health in only about 2 months. Thank you for being here.